everybody. It's nice to see you. This is Database episode 3. And today we're talking about something that I have a lot of interest in, but maybe not quite the depth of knowledge as the Convex co-founders who I'm chatting with today. So we have Jamie Turner, the CEO of Convex, and we have James Cowling, the CTO of Convex, both who have a very deep and extensive history with the technical side of databases and SQL. Hey guys, how are you? So today I have some questions. I have questions about the history of SQL, about the history of databases, if those are in fact different things. And I'm kind of curious about the arc. You know, there seems to be a theme here on the database episodes where we're talking about the rise and fall. So we have the rise and the fall of the edge and the rise and the fall of the single page app, which rose again, by the way. And now we're talking, or at least I'm interested in learning more about the rise of SQL, the fall of SQL, and its heir apparent NoSQL, who couldn't really maintain its time on the throne. And now we're back the rise again of SQL, of MySQL, and especially Postgres. Like, people are passionate, very passionate, and it makes sense. I mean, the database is such a critical, fundamental choice for developers to make early on in their project, lest they have to face some kind of gnarly migration in the future. So it makes sense. I think maybe one of my favorite things about the passion that developers have around their databases is that everybody is terrified of scale. It's like they're like the number one thing. How does it scale? How's it going to scale? When we know, in fact, there's a lot of projects that we all put out there that probably really never need to go beyond one machine. In fact, Notion ran their entire company on one large instance of Postgres for the first 5 years of their existence.
Oh, absolutely. I mean, Airbnb don't have particularly many databases in the critical transaction path. Same goes for many companies don't actually have that large a database cluster.
Yeah, we could talk about this a little bit later. I definitely had this thought the other day when I was thinking about this episode. What if there were a database that was created to optimize for like extreme simplicity at the expense of assuming you'll never have to run it on more than one machine? The first thing I wanted to dive into, James, maybe you are a database researcher. Maybe you can speak to this. SQL was created in 1974, 50 years ago by some clever folks, Donald Chamberlain and Raymond Boyce. What exactly happened at that time? So what was happening in the computer world that necessitated the invention of the SQL 1.0?
Yeah, I think, what precipitated that was the invention of the relational database, which is, I mean, to me, people might be offended by this. I don't think SQL was the key innovation in the history of databases. The relational database management system, the RDBMS, that was the innovation, right? And SQL was a declarative language that one would use to query an RDBMS. So at the time, now this is 50 years ago, this is before even the concept of abstraction in programming languages was invented. So this is back when people were developing programs in really very primitive way with global variables and even the concept of information hiding. SQL was really kind of an advanced concept, right? SQL was designed for data querying, data warehouse kind of querying situations where you have items in a store, for example, and you want to go and issue interactive queries, text-based queries, likely, to find out how many items are in stock, for example, or to query manageable data sets. SQL was designed in a declarative way. And when I say declarative, what I mean is when you write a SQL query, you don't say how to execute the query. You describe the results you want to get. And then a query planner goes and figures out how to execute that query for you. So you say, hey, I want to know all the customers that have I don't know, last name field that's missing that are in Georgia for whatever reason. And the query plan would go figure this out. So this is, way, way, way back when, like I said, I think 74, or it was certainly the 70s. And later on in the later 70s, you had like DB2 and these very pioneering databases coming up, but designed for interactive querying of manageable volumes of state in a declarative way. And it really followed the birth of the relational database, which is such an amazing, I think, evergreen abstraction.
Is it worth differentiating between SQL and the RDMS itself? Like the way that you're describing it sounds like there's actually kind of two things here. There is the concept of relational data storage, and then the philosophy or concept, I suppose, of actually querying that data out of that. A lot of people might conflate SQL and the database. Is it even worth separating those two kind of ideas apart?
I'll let Jamie jump in, but one, I think the RDBMS is an incredibly good abstraction or data model, and I think SQL is a pretty terrible query language. Settled on.
Well, tell us how you really feel.
Yeah, I actually think that there's this demystifying databases idea. It's easy because modern databases are so powerful. It's easy to imagine that fundamentally databases are a very sophisticated idea from a data modeling perspective, but they're actually relatively simple, right? So, I mean, really relational databases are kind of bringing a practical implementation of a lot of the ideas that were first formulated with like relational algebra and stuff like that. And for a lot of developers, I think one way to think about it is it's not much different than what you do with your data structures, right? So you have a type T, right? And then you're going to have probably a lot of those, right? So you could view that as like an array or a vector of T's. And then some of those may have references to where they have child elements or they have pointers in C or something like that, or it's a nested data structure. And so they have these references that go out to other things, right? Or type T2 or whatever. And that's kind of about it, right? It ends up that way of modeling data is incredibly flexible, that most of the things that humans want to be able to organize, you can take collections of things, lists of things that can point to each other, and you can model almost any kind of information that way. And in fact, in our programs, as I was just saying, it's kind of what we do. We have lists or arrays all over the place, right? And we have point references to other objects, and they can have lists inside of them. But at a certain point, when computers become large enough, you start to say, well, you're not really going to hold this all in memory, and you're not maybe going to manually write the traversal code to go follow all these links. If you wanted to have some mechanism to efficiently retrieve the things off of, let's say, a slower but persistent medium like a disk, then you're going to want some kind of, library in the middle there, some kind of engine that can make sure it only fetches the things that are necessary, and that it reduces, redundant fetches and things like that. And so relational database management system is kind of a means to, have that same lists of things that refer to each other, to have that all managed on disk, and to give you, a couple of things you need to do that efficiently. One is this query planner that makes sure to go, grab those things in a way makes efficient use of the disk. And the second one is that if you're going to commit objects with references to each other, you typically want to be able to know that they all committed or none of them did, so you don't have dangling references. And so RDBMSs are typically transactional. They provide atomicity, where they'll ensure that these things will commit together, basically. And so this is, in some ways, the fundamental building block. SQL happens to be a way to express a desire to a query planner, but there's nothing intrinsic about relational database systems that has much to do with SQL. SQL is just one manner of expressing a desire to fetch certain data. You could also just write that code by hand if you wanted. And so, yes, relational database systems are a very fundamental, big idea. And SQL, in some ways, it's a very popular means of giving a command to a relational database management system, but it's not inherently the same thing as relational database management system.
Now I need to walk back my hot take slightly and give SQL credit where credit's due. SQL was well designed for the time. Now the time was 1974. SQL was hugely influential, and it is the lingua franca for talking to a database. right? It's just the standard language for talking to a database. It doesn't have particularly desirable characteristics in the present. We can talk more about that. But I think when people say they love Postgres, for example, I doubt they're saying they love writing left, inner, join, whatever, and giving query planner hints to try to get it to do what they mean. I think probably what they're saying is they love transactions and they love relations, and maybe they love consistency. Maybe they love having a type system.
Right. Maybe they love it because they haven't seen anything better yet. They don't know what they don't know, and they're just like, well, this is a very powerful way for me to write and query the data that I need. Yeah, I think I would agree with that. It's not the language or the query language that people love. It's what it lets them do.
Yeah, I mean, even just a really tiny example of like the very different expectations of developers in the 70s, right? So we did have these fundamental ideas. We want a way to express this manner of computation and getting the data on disk, but like there wasn't a cultural expectation in those days of things like, field autocomplete, right? And so, whereas now, developers are quite upset if they don't have that. And if you had that in mind in the 70s, you probably wouldn't start select with select space and then you type a field, right? Because an auto completion system has no idea what table you mean. You put the table later, right? So in fact, there's kind of been some other query languages that model relational, mapping. That's one of the things they've tried to fix is like moving the table definitions earlier so that you can get better type completions of like the subsequent traversals. Maybe another way to think about it is like SQL is not very left to right, right? Like a lot of the times you say the origin thing later than you say the derived things, right? You say the fields first and then the table later. And so there's been other like query languages that try to do something a little closer to like shell pipelines where you always flow left to right, what feeds into what. And SQL doesn't quite work that way, right? So there's a lot of these, like if you were redesigning a querying language, you probably would rethink some of these things because like modern developers have these expectations about ergonomics that SQL just didn't anticipate, and nor should it have. It was 50 years ago it was designed.
That is a great segue into the attempts to perhaps find solutions to the challenges that you're describing. NoSQL comes to mind, but I just have a sort of branched off question before we get into that. Back in 1974, the late 70s, the database itself, was it networked or was like, so you're querying a database, is that just on your machine or is that shared amongst a number of terminals? Do you guys happen to know the history of like how that infrastructure was set up at the time?
Personal computers weren't around back then. This is how far back we're going, right? I mean, at least they weren't in common usage, right? So probably people were using this on some kind of centralized machine at their workplace.
EP1 or something. And
the terminal for time sharing, et cetera. Yeah.
Yeah, fascinating. Yeah, because I mean, the questions around transactions and things like that kind of only need to make sense in the context of a number of different users acting on the database
Absolutely.
at the same time, right?
Yeah, it's another great example of how much the world changed, and like all that could be expected, right, is in those days you're more talking about new means of general information access, right? And then the later stuff that comes up like high concurrency and isolation levels and your networks and begin and commit over the wire, what happens if the connection drops. And it was very difficult to anticipate all these things would become problems later on because in those days it was this more abstract, like here's a way of expressing information retrieval in a kind of relational model data set. All those real world things, it's impossible to anticipate all those decades earlier.
It is completely and totally fascinating to me that the language designed in that environment in the 70s still works and is still so widespread in a future and in a context that is so wildly different from what it was. Now, what people are trying to accomplish is the same, but the idea that this SQL, this database was, on a mainframe and there were only terminals, there were no personal computers at the time. The fact that that concept still applies so effectively to today's massive scale and, millions of different machines, that to me is it feels very elegant. And maybe that comes back to the fact that it's so closely based on relational algebra. And at the end of the day, it's effectively performing math on some substrate, and the substrate can change.
The more you talk, Tom, the more I feel bad for saying SQL's terrible.
Well,
The other example I can think of is TCP. These are like protocols, languages written at a time, like TCP was written before the internet looked anything like it looks today, and we still use it and it still works. And SQL was written at a time that absolutely predated web apps because it predated the web by several decades, and yet still works. Right. And I think, one argument we'll make probably later on in this podcast is that we can move forward now, but we should understand what was good about SQL and what was really good about relational database systems, so we don't throw them out, because there have been several prominent attempts to dethrone SQL along the way that have failed, frankly.
Yeah, I think there are truly, truly very few things in history that are typically invented once and then don't change for hundreds or thousands of years. Things that come to mind are the wheel, for example, or the screw, which has a fascinating history. That said, it does feel like SQL has a lot of obviously great and powerful characteristics to it, but surely there's got to be an improvement, a better way. Going back to just because it works here now and today doesn't mean that it's optimal for today's environments and today's infrastructure. And I suppose that was maybe like the driving force behind some of the anti-SQL movements of the early to mid 2000s.
Yeah, I think 2011 might have been the peak, but James,
Yeah.
all about this.
Yeah, I was in that wave, for better or worse, everything. So the engines behind SQL are useful enough that people have moved hell and earth to make sure you can keep getting to them through SQL, is what's actually happened. But I do think that there is this latent desire that keeps coming up to move to evolve the way we address databases. And so one of the best examples of that is the one you just alluded to, Tom, which is the quote unquote NoSQL movement in sort of the 2009 to 2015 era or whatever it was. So, and I think what's interesting about that is, like, most things are actually not technical. At least most things succeed to any degree in the market. They're usually socioeconomic and things like that. And the thing that started changing, I think that was correlated with the rise of the software developer as the most important labor type, the most important worker type in the technology industry, right? And so software engineers, especially at smaller companies, were often starting to be the decision maker about technologies that were being used more than, let's say, a database expert like a DBA. And software developers, there was the rise of languages like Python at that time and JavaScript and stuff like that. And software developers really like their programming languages, as you would expect. And so I think the rise of things like MongoDB, which is sort of like, hey, you have Python dictionaries, just give us those and we'll give them back to you later. And Redis, right? It's like, hey, we've got all these data structures built in, and it does algorithmy stuff. And it became immensely popular because they were really speaking the language of the software developer, and they were making it so that the database's language was closer to the language that the rest of the application was written in. And so, yeah, I think that's ergonomic hope and aspiration has been there. Even the excitement these days, and every time a new ORM comes out, like I think Drizzle's the latest one, everyone's excited about. Prisma before that, like, we still love the engines, but software developers are desperate to figure out how to replace the SQL layer, really, if we're being honest, with something that's closer to the code, closer to the way that they like to express themselves in the rest of their application.
Right. So we want all the good stuff, but we also just want to be able to do it in JavaScript. And like, I don't want to have to learn a whole new language, or it's cumbersome or non-performant. It's like, just, is there any way we can just continue to write and access my database in the same way I would write a UI?
Yeah, I think the story of NoSQL is the story of the web and the web developer. Because, I mean, there was I'm just going to give Mongo credit for being the premier NoSQL database. I think is probably fair, although there was many NoSQL databases. Mongo just had a meteoric rise, and I think I mentioned 2011 before. I think 2011 is when like Mongo was more popular than Postgres, and it had more time in the sun after that. And so all of a sudden, this new database came along, and it was very popular. And it was very popular for two reasons. One, it was very ergonomic for initial development. So it's very easy to get started on. And two, it was web scale, which is a phrase we don't really hear that much anymore, but web scale was a big catchphrase back then because everyone thought they were building the next, I don't know what they were building at the time, Google, I don't know. Everyone was building a big scalable app, and there was a belief that relational databases and transactions didn't scale. So we had to throw away, 40 years of database evolution and start again with this new model. Yes, it was NoSQL, but also it was no transactions, no consistency, no type safety, and a whole bunch of other no's that came along with it.
Right. So that all tracks for me. The ergonomics were so good, and the NoSQL effectiveness was also, it worked. It was great. It got the job done.
Wow.
Up until some point, like something happened.
A point.
For a while.
In like 16, 17, 18, when I'm not sure exactly what it was, but if I'm speculating, it feels like there was a lot of companies that had built on Mongo or other NoSQL backends that started to run up against their web scale. I remember that term. Started to run up against their web scale challenges, and maybe the ergonomics of solving those overshadowed the easier ergonomics of the actual day-to-day access.
James's point about like the needing to analyze what you have to know what to keep and what to is unfortunately the losing out on the transactionality and the consistency. And databases, your project either never went anywhere, in which case it didn't really matter what you used, right? Or if it succeeded, eventually your project size, your traffic level, your complexity, what you're making, you usually start to run against the kind of pains that a proper RDBMS, solves for you. It's you start to run into requirements that the different way of modeling data under the covers, not having relationships, not having type enforcement, not having transactionality. The bigger your project gets, the more that stuff really kicks you in the teeth. And so these database systems started to have kind of graduation problem, issues where the most successful projects would struggle mightily to stay successful on them. And that is a great way to demolish your reputation, right? That your most successful, loudest voices using your system are your least happy customers and users. Yeah, I think it's the way you put it, Tom. It's like the ergonomics were extremely appealing. That remained true, but the other things you'd given up ended up mattering a lot as your project matured and became more complex.
I think, startups and software teams starting a new project very justifiably want to optimize for velocity, and that is generally the right choice. But I think you have to ask, when you're optimizing for velocity, are you doing so in a sustainable way? And so there's just no question that Mongo, for example, was much easier to get started with because you could just dump your data structure straight into this thing. You didn't have to define a schema ahead of time, didn't have to deal with this complicated query models, etc. But at a certain point, a lot of companies found, including a company that Jamie was deeply involved in, that velocity really plummeted because you'd given up guarantees that made life very difficult for you. In particular, you gave up consistency and durability in many situations. Mongo has improved dramatically. I think Mongo is actually a pretty good database in many respects today. But at the time, I think it's fair to say Mongo was not a reliable database, was not a consistent database. He gave up guarantees that really, really slowed teams down.
Yeah, the other element of it, aside from the design portions that you missed on, were just implementation things. So database engines are really complicated things to make robust and world-class. And so I think two pieces in particular of RDBMSs that are not as much about their design, but more about their implementation or some of the other pain points. One is making a storage engine, the thing that actually saves data to disk, that's high performance and durable, is an immensely difficult job, especially in the era of spinning disks. And when Mongo rose, we weren't yet moved to Flash, so you still had to have a storage engine that worked pretty well on rotational media, right? Regular old hard drives. Mongo was competing against InnoDB and Postgres storage engine and things which had just so many dev hours put into hardening it and making it actually work and covering all the edge cases and making it performant, solving data adjacency issues. And so that tended to cause issues as you scaled. The second implementation thing, as opposed to design thing, is that designing and hardening a robust replication system takes a really long time. And Mongo hypothetically had a great one out of the box, at least in principle, but in practice, it didn't work very well for the first 5-6 years. It took a long time to harden it, and so when developers switched, they not only were these design things around consistency and relationships that ended up hurting them from a model perspective, but the relative immaturity of the storage engine and the replication infrastructure, that was the second element that operationally was a giant pain to figure out how to get that level of service you were used to from something like MySQL, InnoDB, and built-in replication. It wasn't competitive.
Right. So really the serious problems started to arise at the levels of scale where you desperately don't want those problems to arise.
Yeah, and not necessarily scale out, but scale up. Just like once you start caring about your product enough, you need things to be correct. And I want to say a very obvious, or hopefully a very obvious thing, which transactions are an amazing concept. And a transaction, probably we all know what a transaction is. Transaction is a group of statements that will happen all or nothing, so atomically or not, and they will be durable and atomic and isolated as well. And transactions are amazing because transactions allow you not to think about race conditions and interactions of multiple parties. And so it's maybe hard to imagine now because most of the time these days people do use relational databases with transactions. They might be running in read committed or repeatable read, which that's a topic for another time. But at the time, this thing called eventual consistency was hot, right? Everyone was talking about, well, we have to build web scale apps. And for some reason, and this was a big thing in the research community at the time, back when I was active researcher, people were saying, well, we have to build systems that are partition tolerant. So they have to keep running even if the network splits in half. And as a result, we just can't have consistency because you can't have consistency and availability and partition tolerance all at the same time. And so there was a choice amongst many web developers and frameworks to kind of give up on consistency and kind of have best effort, eventual consistency, which turned out to be a very difficult model to program and meant the developer had to really think about race conditions all the time. And one thing that's really great about relational databases in strong isolation levels like serializability is you don't have to think about race conditions. You just run a query and it just happens.
Right. It sounds sort of like UDP when what you want out of a database is typically some guarantees.
Yeah, I mean, technically UDP is faster than TCP, right? There's less overhead.
Yeah, right.
Now you have to worry about what happens when your message goes missing or gets sent twice somehow. And, you end up reinventing TCP.
As soon as you said that, I'm like, yeah, UDP is a great, it's a perfect example. It's another mistake I've made as part of teams before, right? Is like you're doing something and you're like, I need performance here. You grab UDP, after you're 4 months of the project, you realize you've reinvented TCP poorly, but you have your retry and, you're resequencing things in order. So yeah, it's the same thing with databases. Eventually you're like, oh, okay, well, these things do need to commit together. I guess we're going to invent our own two-phase commit thing on top of a key value, a Dynamo style thing. It's just a disaster. And the things you're trying to hedge against, right? Like partition tolerance almost never happen, right? You're you're trying to prevent a black swan thing from happening, right? But every day committing to just getting slapped soundly across the face. We're just going to have every day suck. And we're going to make even more mistakes because this model is so much more complicated to work with. But boy, that thing that could happen once every 4 years, that we're going to be laughing on that day,
So making up,
Fridays.
Making up weird straw man examples here. No one would ever do this. No one would ever consciously give up consistency for partition tolerance. Lots of people do. And I actually, one of the things I do sometimes is advise companies on database infrastructure. And there's tons of big companies out there that just occasionally just have wrong results in their database, right? Because they've optimized for availability at all times. When the reality is if AWS is down, just take the afternoon off. It's okay.
Yeah.
For most companies.
Right. If you're ever chatting with the team and they're getting some advice and they say, so we read the Dynamo paper, and then, or they say, so we were reading this stuff from Google, about Spanner, and you're like, oh no, what did you all do? They're like, okay, well, we have 400 requests a second, and now we've got them going over 50 shards, and you're like, oh my gosh.
Defense of Postgres, almost everyone should use Postgres before they build their own database. Almost everyone, right?
Yeah.
Seems reasonable.
Yeah.
I don't know. I wouldn't even know what to search in YouTube, like how to build a database from scratch. I guess you take UDP and you add some kind of handshaking to it, and now you have consistency. That's okay. I love this. I love this discussion because there is this clear arc in the history of developers and data and how we as developers are able to access to it to write it. And then occasionally something we build actually does work. And it does require hundreds or thousands of requests a second or a minute. And it requires all of these built-in, super powerful, transactional, highly consistent characteristics of Postgres. And yay, you're very happy now that that exists. So as the pendulum has swung back from SQL to NoSQL, we're back to SQL. It seems that what we're talking about is also fairly well recognized in that, okay, SQL has, sure, a lot of really wonderful, incredible things, but I don't like the language. And so there's been a number of attempts to, I don't know, create these ORMs, I suppose, supersets of more ergonomic languages. And I'm wondering if that feels fundamentally like the right balance when that pendulum goes back, in that, do we just sit on Postgres and create a more ergonomic language?
It's the best you can do of a bad situation in many regards.
Yeah.
So one thing that if folks haven't seen how like large companies run their databases, because a lot of large companies run on sharded MySQL or Postgres. A little while ago, like MySQL was actually the choice for large companies, in particular because Facebook had run and YouTube earlier had run MySQL at very large scale. So MySQL had been kind of tested at high scale. Now Postgres is having its renaissance, but almost no large companies have their developers writing SQL queries in the critical path of user interactions. So typically they've got some layer on top which hides SQL for a variety of reasons. One is SQL's query language is very brittle. It's very, very easy to write a bad query that destroys your entire database.
I once brought I was working at a company and we had a few million customers, probably 100,000 online at any given time. And I wrote just a raw SQL query, and I did sort. I was like, sort by largest. And apparently we didn't have an index on whatever I was doing, and everything slowed down significantly. And our CTO at the time was like, oh yeah, no, don't do that. So I learned that they shouldn't have let me do that.
Yeah, this is the second issue. So the one is that you can write bugs in the type system. It's very easy to delete data, for example, accidentally in SQL. So you have an ORM or something on top of that. But also the query plan is very unpredictable. So you write a declarative query, and you generally, at any big company with a very high throughput web app, you know how you want that query to be executed. You know there should be an index, etc. And SQL will go and try to do that for you, but sometimes we'll get it wrong. Right. And in the live query path of a website, no, you do not want to be doing an unindexed query like you were doing, Tom. If you select a random element from a table, it may just materialize that view, meaning copy the entire table, which might completely take down your company. And so generally, large companies treat SQL like a layer underneath a relational key value store. And the developers just use the relational key value store, and they do a bunch of query hints or force index statements underneath to try to subdue the dangers of using a very expressive, very unpredictable query language in an environment where you actually need very, very predictable performance.
So is there like a whole team of people just who are like 80 feet underground managing this very, very sensitive layer such that the rest of the developers in the company can't bork everything?
Go say hi to
Yes.
you pretend. Yeah.
Yeah.
Absolutely, there is.
Okay. So
Yeah. Well, yeah, if you really want to be able to set loose 1,000 or 10,000 or 50,000 developers to have quite a lot of liberty in being able to make new product features and move somewhat quickly, yeah, you have to. There's no way to pull that off if they have the full power of SQL available to them. It's hard for even SQL experts to not accidentally write something that's highly problematic. And so, yeah, there is, as James said, it's kind of like relational ORM kind of layer, essentially all of these companies, so where the raw SQL is hidden from them. And what's exposed is just expressive enough to solve application problems, live site application problems, but doesn't provide the amount of expressiveness expression in order to take down the database or traverse every record in Facebook's users table or something like that, something devastating.
for me, that all sounds just very expensive and specialized. And I feel like it leaves smaller companies and startups in a bit of a lurch where they're left to figure that out on their own or last shoot themselves in the foot.
Big companies generally present some kind of limited ORM kind of layer for development within their company, right? Oddly, it kind of traverses through this very expressive layer of SQL back down to a B tree. It's kind of like B tree, SQL, B tree. And then developers, they don't have the team of tens or hundreds or thousands of people to do this work. So they either use SQL or maybe they use something like Firebase, right? Which is a pretty successful NoSQL database, has some undesirable properties, in particular the lack of a relational model and the lack of an ability to write complex transactions easily. And so for many respects, Firebase developers say some of the similar things as they did with Mongo. They love it at first. Eventually, they have to grow out of it. But yes, it's interesting. Like in some respect, I'll make a bold statement here. The only developers who are really throwing down on SQL itself these days are either folks doing analytics work, which is a great fit for analytics, or small team developers, because big teams already learned that this is not the right abstraction for modern applications.
And those small teams just haven't hit the problems yet. They'll move off of it too, eventually.
Right. I was going to say it's like small team developers by necessity, and they're like Icarus. They're just flying too close to the sun.
Yeah, the small teams. I mean, even if you read the postmortems of smaller teams and stuff like that, missing an index here or too many joins here that cause some materialization explosion or whatever, like it's a very common cause of issues. And so I actually do think for a lot of small teams it's maybe one of the impediments to like fully empowered full stack developer who really is able to achieve kind of mastery of both the kind of product development side and the backend state management side, is that that's the sophistication of what SQL databases require in order to not accidentally misuse them. It's just very, very high, and very seldom do most engineers want to spend enough time to go develop all that expertise. Even if some of them on the team do, scaling that out to every developer writing code at the company is really, really hard. And so normally there's just a series of incidents you're going to have until you move on to something else, or you adopt an ORM that helps subset the language for you or whatever.
Now, if we were to say what do developers actually need? Like, what would the modern alternative of this be? Because it's easy to critique something that already exists. I think transactions, absolutely. Single shot transactions that run to completion and can perform many, many actions inside that transaction. So you don't have to have rounds of interactive communication between the client and the server. I think type completion, type safety, this is something that developers have just come to expect, especially in the last few years. And I think it's a great thing to expect. And I think that the query primitive that you probably want looks like range scans in a B tree, which may not mean a lot to some listeners, but basically what I mean is just being able to query ranges and have indexes on those. And that is generally what most queries in a production application look like. Mostly you're not writing very, very complex, deeply nested SQL queries. You're writing some basic thing. Hey, give me all the users that, I don't know, haven't paid their bill today. Right. And these can be answered pretty straightforwardly using, indexes into tables. And the reason why it's pretty straightforward is people do this already when they're programming. We already know how to query data structures. And this is just accessing another data structure.
I think that's a great way to think about it. And to bring this full circle, we have now 50 years of understanding the fundamentally strong points and some of the weaker points of all of this prior art that we have when it comes to relational databases and SQL and their query languages. And obviously, we are very close to this problem. We all, I mean, you two founded Convex. I work here now with you both, and it seems to me like Convex is a really intentional attempt at rebuilding some of the fundamental database concepts that work really well and intermixing the very high ergonomic experience that developers are endlessly seeking. And I really don't mean that to be like a shill. Obviously, we work there, so I believe in the product, but I actually so deeply believe in the vision that you two have had for this, which is why this conversation for me is particularly fascinating, because I have this privilege of learning from you about all of this, and it paints for me a very deep and clear picture about what we are trying to accomplish with our product at Convex. And as you know, prior to me working here is what really attracted me to the company when I first. It was like a revelation for me that I hadn't experienced before. I got the power of this database, and I got the ergonomics of what I knew. And then it all just kind of worked, and I was left wondering, like, what's the catch? Like all of the things that we've just talked about. So am I painting too rosy of a picture, or would you characterize what our goals are, or what your original vision is and was for Convex?
That is the aspiration, right? For as absurd as it might seem, the aspiration is Convex wants to be the having your cake and eating it too company, right? So it's like, what we've attempted to do is preserve, even if we're shills, we're at least being consistent in our principles here. So everything we're saying now, it's embodied in the platform that we're building, which it means that Convex is a relational database management system. It does not attempt to revisit all of those things. It thinks those things are excellent, but it does provide ergonomics that are in the programming language kind of model. So it does attempt to move forward the relationship between state management and applications and the backend in a much more ambitious way. And that does mean it's re-examining SQL, but it's not really re-examining relational database management systems. It's heartily in agreement with the design of relational database management systems. And so just even to keep us honest, right? One of the things I mentioned is that in addition to the model pieces of it, the second element that was problematic about the previous NoSQL movement was the implementations took time to mature, right? And so Convex is built on top of, this is a big secret, but Convex is built on top of, it's an open secret, relational database management systems. We use Postgres underneath, we use MySQL and Postgres both underneath Convex, and we use it for its excellent storage engine that provides asset guarantees, and we use it for its excellent operational replication infrastructure. It's so good at that, right? It would take us so much work to recreate that. So we are using in our minds, the right balance of the parts about relational database management systems that are venerable and should be venerable and are amazing. But we are replacing the upper layers, just like other developers are with ORMs. We're just doing it in a way that's much more comprehensive and ambitious.
And to broaden this like beyond convex, like what are the primitives? What are the core abstractions that like the winning models? Like the relational model just works, and partly why it works is it maps to the real world, right? It's just lists of stuff that relate to items in other, the relational model came out of like cabinets, like physical cabinets, and like files, right? And now I have this person let's look up their company in a different cabinet. Relational model really maps very well to real world concepts, which is generally what we're trying to map in a database. Like, hey, there's a user, but they have a team, and that team has, I don't know, an admin, etc. Relational model, wonderful. Transactions is so incredibly important. And I think if you don't have transactions, you have to deal with distributed systems and race conditions and concurrency control in everything you do, which will lead any company to grind to a halt eventually. So transactions are amazing. Relations are amazing. And I think type safety is something that's really amazing too. I think people have really come to learn that the ergonomic benefit of being able to have type completion and to know your code's correct because you wrote it and it compiles, that's also really important. And then I think there's just the realization that programming languages have matured so much since 1974, right? We don't need to have an alternative way to query database that's like text-based, like it's in ASCII, right? We can query a database with a program now, right? And I think TypeScript is a good enough choice, right? TypeScript's a good enough choice because, hey, everyone uses it, and it's there's pros and cons to TypeScript, but it's kind of the winning language right now, at least for web development. And so, yeah, if someone builds a database, and like we have, where it's transactional and it's consistent and it's relational, and the query language is TypeScript, it really, I think, gives developers what they need.
I mean, I've thoroughly enjoyed using it, and yeah, TypeScript, I'm a huge fan. Pros and cons for sure, but I've oscillated between TypeSafe and what are not type-safe languages called?
Dynamically typed.
Yeah, exactly. I've oscillated between those, and in review of the last 20 years, can confidently say I enjoy developing more in type-safe languages. There's a slightly more, I think, front-loaded overhead, but it absolves me in the long term of a lot of other overhead. And so I mean, I agree. I'm a proponent of type-safe. I think I'm excited I'm really excited right now that so many people care about databases, and there are so many discussions and opinions and thoughts and commentary about the state of databases. I think that's nothing but a net positive. And I think the future is really bright for application developers. And there's a plethora of options suitable for different needs. So, what a time to be alive, right? Look at us. Look at us now.
Yeah, for sure.
Certainly developing is a lot better these days than it used to be. That's for sure.
Yeah, and it's awesome that developers have such high expectations, because it makes it a really fun challenge when you're creating something new. Like you really want to put the work in to, if you can make something that they find extremely pleasing, you've done good work, because the developer standards are very high these days of their tools that they use. I think if there's one magic wand that, if we were able to wave to change about the way we're all talking about this stuff right now, it really is about this conflation between SQL and the rest of the RDBMS, right? Some people, like the thing that we're doing, let alone what some other teams are doing as well, is sometimes people will say, well, you're crazy to take on SQL because everyone loves SQL. And that might be true nominally, with labeling. But if you look at people's behavior, SQL is the one part they're not crazy about, right? We keep Postgres as types, we keep Postgres as storage engine, we keep its replication, but then Drizzle comes out and we can't wait to grab it, right? Then Prisma comes out and we can't wait to grab it. SQL is the one thing, if we actually looked at our behavior as application developers, not in the analytics space, but in transactional application development, we're constantly seeking to find something better than it. And Convex is fully in alignment with that. We too love all the relational storage engine parts about these relational database management systems. We respect them and we use them, but we too are looking for something better than SQL. I think that to me, it's a little like if someone said, "Hey, arrays are forever," right? I'd say you're probably right. Sequences of things are basically forever, right? Similarly, RDBMS are forever. Relational database modeling is probably forever. But if somebody said to me Fortran is forever, and I go, well, I don't know about that, right? Fortran has lists, but we'll evolve the ways we talk about lists, right? And to me, SQL is more Fortran, and relational databases are the fundamental way of modeling computation and storage that will stick around for a long time.
Okay, thank you guys so much. Let's leave it there for now. I hope anybody who's listening has enjoyed that conversation. You can find us all on Twitter, X, email. We're easy to get a hold of. But guys, I really appreciate the time. I appreciate being able to chat and learn from you. So thank you very much.
Thanks.
You come.
Have a wonderful day. Bye.